Ford reports one of its plants in Louisville had to stop work earlier this month because of the shortage.
And you know what happened here is that the Chinese government, according to our reporting, installed malicious microchips on super micro made.
Ideally positioned to gain a boost from silicon nationalism, making things here in the U.S.
Hello, everyone, and thanks for tuning in to today's webinar, Big Game, Running for Reliable Access to Advanced Computer Electronics. I'll now pass it off to our moderator for today's discussion, IEEE Senior Member and IEEEUSA Innovator in Residence, Terrence Yo, who will introduce our speakers. Welcome, Terrence.
Hi guys, welcome to the Big Game. We are really on the hunt for reliable electronics. And this actually came all about due to that National Defense Appropriations Act. That was NDAA in fiscal year 2021. It calls for the Secretary of Defense to work with the private sector through a public-private partnership to ensure the development and production of advanced microelectronics that are measurably secure. Now, what does that mean? It's critical that the U.S. protects its manufacturing interests, its infrastructure, both in terms of the domestic infrastructure, in terms of the commercial infrastructure, in terms of our defense infrastructure. And without doing so would have extreme and undesirable consequences for our inability to meet the near-term as well as the mid-term U.S. critical infrastructure requirements. So we can't wait very long for this technology to come. We can't wait for it to be shipped over from another location. We need that to be domestically fulfilled today in order to safeguard our national security. So what we have here is a problem that needs a solution. But fortunately, IEEE, which advances technology for humanity, we're all a set of engineers, and we like problems because then we generate solutions. So we're looking for solutions. And fortunately, we have an all-star collection of leaders today in the industry that has unique insight into the situation and are working towards effective solutions. So please welcome this all-star cast. Our first one is Kevin Matige. He's a Senior Corporate Vice President of Global Technical Systems. We also have Vern Boyle, Vice President, Northrop Grumman Mission Systems, as well as John Costello, Corporate Vice President, Microchip Technology, and Dave Bass, the Chief Technical Officer of Integra Technologies. Gentlemen, thank you so much for being on this panel. This is a very, very important topic, and we're really looking forward to hear of your insights. I'm gonna start off with a 2-minute, 3-minute intro for each of you, and what your background is, what your focuses are, what your mission is, and what kind of solutions you're bringing to the table. So Kevin, why don't you start the panel and share about yourself.
Thank you, Terrence. Really appreciate that. First, thanks to IEEE, thanks to the distinguished members that are on the panel, and also to all the guests that are joining us. Appreciate all of this. I think it's a great topic, and I think it is prescient. I am Kevin McTighe. I'm the Senior Corporate Vice President for GTS. We are a mid-sized DoD prime developer and integrator of mission-critical systems for the DoD. Our products include the Common Processing System, which is the brains for the Aegis weapon system. It's also used by the ship self-defense system. It's used by the guns weapon systems, mission planning systems, Aegis Ashore, and a number of other programs of record. We also build the Battle Force Tactical Trainer, which is a shipboard distributed simulation capability. We build the CANE system, which is a C4ISR capability for the Navy. And we are an NSA Commercial Solutions for Classified Trusted Integrator. And we develop microserver technologies. The key elements here that I'm going to be talking to are really that we produce COTS-based high-performance computing systems, and we do that at the integration manufacturing level. So I'll be talking to that some more. Our background includes supply chain vetting. So to the point of this discussion, we use guide-up controls, we use tamper and counterfeit inspection, source of origin, trusted firmware, post-production, burn-in testing, and things like system acceptance and verification. And that vetting goes through all the way through that process. Is that sufficient for where we are today in the DoD? I would say the answer is it's a moving target, and we need to lead that target. We have to continue to adapt to meet the challenges, and really they revolve around global commercial microelectronic supply.
Well, thank you, Kevin. Thanks for all the support that GTS is doing in support of this really critical infrastructure. Vern, could you introduce yourself and your mission?
Yeah, sure. Thank you, Terrence, and good afternoon, everyone. Appreciate the opportunity to join the conversation today. As it said, I'm Vern Boyle. I'm a vice president at Northrop Grumman. We're obviously a large defense prime, an integrator of a variety of defense and intelligence systems, ranging from aircraft, weapon systems, spacecraft, onboard mission systems such as radars, and defense systems. So we're very interested in helping to understand and address the problems we're discussing today. Often we're integrating electronics that need to be available. Sometimes we're also designing and fabricating our own mission critical electronics, which we'll talk more about throughout the course of today. But very important topic. I look forward to the conversation, and thank you again.
Thank you, Vern. John.
Hi, Terrence. Once again, thanks to IEEE folks for inviting me, and again, I'm honored to be on with such esteemed colleagues. I'm Vice President of Government Affairs at Microchip. Previous that, we were Microsemi, and we were acquired a few years ago. To that end, we're one of the largest suppliers, if not the largest supplier of DoD components, mil standard. We have a very broad product line, mostly board level electronics. However, we do engage in systems in our frequency and timing division. We've been in the A&D space for decades and been building mil standard parts for decades. So we really understand the needs of the primes like Vern over at Northrop and Lockheed, Raytheon, Boeing in terms of mission critical and how it compares to what's going on there with state of the art, which is what we're going to be talking a lot about today. So as the largest supplier, it's very important for us to try to sustain those mission critical devices as state of the art kind of takes over in a commercially driven market. I've been at Microchip quite a bit of time, 38 years in the industry, 32 of those at Microchip. So I've kind of seen that transition from the DoD driven market, the DoD NASA driven market in the 80s during the military buildup to 3 decades later to where it is today with a very robust commercially driven market. So there are issues that we have to address, and I hope to make some good points today along with my colleagues on this panel.
Great. Well, thanks so much, John. Dave?
I'd like to start out by thanking the IEEE and Terrence and, of course, all the participants on the panel today and all the guests for this opportunity to speak about this important topic. Again, my name is Dave Bass, and I'm the Chief Technical Officer for Integra Technologies. We are a US-based trusted full turnkey semiconductor services company headquartered in Wichita, Kansas. The services that we offer include package assembly, full electrical test across multiple temperature ranges, full qualification of components through everything from burn-in to pass and T&H, etc. We have full destructive physical analysis, failure analysis capabilities, and we also offer part procurement capabilities as well. I have about 37 years of experience in the electronics industry. About half of that is on the component side in various engineering roles and leadership roles, and also worked on large to very small computer systems. One of the key blocks I would like to speak to today is problem lessons. In today's world, many automotive manufacturers use older chips that are designed years ago, and that today much lower priority for the chip companies to make because they have such low profit margin versus the newer state-of-the-art semiconductor used in most consumer products like smartphones, computers, gaming, etc. An example of this is the Audi automobile Q7 uses 38 microcontrollers from 8 different suppliers. And many of those tend to be older devices that, if they go obsolete, require complete system redesign, which takes time, and we know time is an enemy. So this is one of the key areas that I'll be looking to discuss with the panel today. Thank you.
Thank you, Dave. And as the audience, you can see that this is a very all-star cast with a very nice cross-section across many parts of the industry. And I want you to be involved in that. I'm watching the stream comments as we speak. So if you have any questions within the topics that we have, feel free to type them in and we'll address it as they come by. So Dave, you did mention this a little bit and pull that thread about automotives and how many different sort of microchips are on there. Many times I see that the cars of today are more like smartphones rather than cars, especially as you're going into EV technology, as they are connected through 5G, as they continually upload and download new information, revisions, all of those things. Those are the questions I have in terms of the blockers. What is the blocker for this immediate availability of high reliability electronics? We've heard, Ford and other manufacturers having problems actually shutting down plants in order to make because they don't have the chips necessary to make these cars. And this is a question to all the panelists. What are these blockers for this immediate availability? What's keeping us from having these parts sourced?
Sorry, we're going to choose a panelist, or we just raise our hands?
We're just talking.
Okay.
Well, commercially, I'm sorry, go ahead, Dave.
No, please go ahead, John.
Well, commercially speaking, cost of operating a fab is a big driver, but in this most recent shortage, it probably had to do with the demand, the low demand signals when everybody thought this Category 7 storm with the pandemic was going on. I guess we didn't have the foresight to realize that everybody staying home was going to drive a larger demand for microelectronics. So from a strict cost standpoint, everybody has the incentive to go overseas, and we don't really have control of it. Now, you had mentioned high reliability. To me, there's a bit of a difference because of the way we define high reliability is more like military or space grade microelectronics. In that instance, I think state of the art isn't that much of a player. It's really the sustainment of mission critical devices, which is becoming a smaller proposition in a bigger picture, which it makes it that business model is much tougher to maintain. So like I said, I think this is pretty much all cost driven and demand cycles, and I think that's what it really boils down to. High reliability, again, you could get into all kinds of discussions on this, because if it's too high reliability, well, there's export control you got to worry about, because if your part's high reliable, it goes in automotive application, but by process it's radiation tolerant, well, then you got an ITAR issue. So there's a lot of things that go into this, and it's going to take a lot of thought and a lot of strategic thinking to make things work going forward.
So that's an interesting take. I mean, in terms of having a large source of this high reliability or rad tolerant devices for commercial use, that gets a problem in terms of export. So you're kind of caught between one way or the other. Kevin or Vern or Dave, do you have any other comments?
Yeah, go ahead. Go
ahead, Kevin. No, please, after you.
Thank you. Yeah, and I'll kind of piggyback on what John was saying a little bit. I agree with him completely. And my comment there is, I'm going to extend that discussion a little bit further into, we haven't leveled the playing field. Okay, the challenge is, we're not addressing currently the not just the volatility, but the security of our mission critical government, enterprise, and commercial ICT. The reason is pretty well understood. It's a dependence on global COTS manufacturing. And we really do not have a handle on the security and the approach to that right now completely. So when we say, what are those blockers, from a reliability perspective, and partially that's what we're talking about here for the DoD and these types of system capabilities, we've got to be focused in then on how can we change the reliance or enable discriminate approaches that put us on a path to trusted access.
Yeah, and I'll add also, I agree with what both John and Kevin said, and I think we're touching on one of the core issues of our topic today, and that is that there are very few producers of these chips. And when demand surges, they decide what the priority is. So, for example, if you have a surge in in-home networking, like we have right now, and you want to produce a lot of in-home networking electronics, that's the highest priority. The automotive industry moves to second or third. And then if you're in the defense industry, you move down even further, right? So I think that's, it's good that there's demand, but it's not good that there's so few suppliers. And so we need to figure out how to address that, particularly in the defense industry and the, low volume electronics that we're normally dealing with.
I fully agree with that, Vern. I wanted to ask a little question about that in terms of, yes, low volume, that tends to be a high cost because and the reliability and of course the yield goes down when you have low volume. Can you comment a little bit about, how the government's been subsidizing over the years capabilities, the trusted foundry and other things like that? How has that worked? How has that helped? And how has that hindered?
Well, there's a requirement for security and trust in most of the government systems and the DoD systems, and for a while that was addressed through a trusted foundry model that we have here within the U.S. As the node sizes have decreased and the fabrication has moved offshore, the ability to address what's needed solely through the trusted foundries is no longer there, right? So now we're in this state where you need to figure out how do I produce advanced node electronics and advanced node products, yet maintain trust. It's an unsolved problem. There are a lot of people working on it. There are a number of programs, and obviously the NDAA identified a number of areas that we need to focus on to address both the availability of these advanced node electronics, but also the security and trust.
Yeah, and to add to Vern's point, when you look at the transition or the product life cycles, government is kind of slow to react, and commercially driven things are not. So as the industry actually transitioned, because I think, we can all agree that when we started building ASICs at some of these onshore foundries, but when the industry transitions into something that may be more flexible like FPGAs, well, all the specs from ASICs don't necessarily apply to FPGAs, and now you got a void there because a lot of companies and primes move to field programmable gate arrays over ASICs because they're faster to market and they tend to be less expensive, and of course they're reprogrammable. So those nodes that they build those ASICs on now, if we're going to transition FPGAs, there's not a lot of governing specs, and so we're kind of playing catch up. So I think that has something to do it as well, because you could be subsidizing a facility that's only addressing a very small percentage of the DoD need, yet the cost rises considerably because those fabs are expensive to operate, and if they're asked to, hey, you got to keep operating, we're going to give you some money to do it, but you're addressing a smaller and smaller part of the market space. Well, something's got to give.
So do you see that as an example of how technology is outpacing the speed of how government works and their understanding of how things are actually done in the commercial sector?
Is that directed to me?
Yes.
Oh yeah, well no, obviously, yeah. I mean, absolutely. I mean, we all know what it takes. Certainly Vern is probably the guy that's most experienced at this. When he gets, when he starts his program, by the time they get to, conception to prototype to first article, by the time Congress decides, how many systems are going to build, by the time this thing even gets on the planner's table, half the parts are obsolete. That's a big challenge.
Definitely so. So, moving on to this trusted availability, as we're seeing that, if domestic production of microelectronics is limited, particularly because of those market forces you mentioned earlier, what procedural, legal, technical solutions exist to source these components from offshore sources or inshore? This is for the whole panel, right? This is really where we're at. We know there's a problem. We all agree there's a problem, but what are the solutions? What are the real solutions we can move forward with?
So, can you hear me? Very good. I changed my audio setup. This is the point where I would prefer you put the slide up for Integra Technologies, please. So if I go back to the obsolescence problem that I mentioned in my opening statement, much of what we deal with at Integra Technologies is component obsolescence, especially in the mil-aero marketplace. As you can see on the left side of my slide, Integra's role in this is through our P&P program, or our parts management program. Original manufacturers often just cannot cost competitively build and maintain the military component lines. The volumes are just too low, as we know, to justify the added expense of carrying those. And unfortunately, that led to mil-aero segment using COTS components that have a significantly shorter lifespan than the weapon systems that they're going into. And with that came a whole slew of problems that we've been discussing here today. In order to fix that, you have to address the issues that got us here. And from the standpoint of cost, that equation still exists today. There is not enough volume in the DoD buying to justify the extremely high expense of the tools required to process these components, resulting in commercially unviable problem to solve. Obsolescence issues continue to cause product delays and high redesign costs. In the short term, the first step for addressing this from Integra is to acquire COTS devices that are scattered throughout the ecosystem. Many times that available supply will meet the near-term needs of a mil-aero production levels and buys you more time for any kind of redesign work that needs to be done. Integra does support many customers with obsolescence issues through various activities of testing, validation, qualification, services, etc. And the DoD program offices need to invest in this kind of support from companies like an Integra. As you can see on the right-hand side of my slide, we also offer a full range of component development services working with third-party trusted suppliers. For example, we're working with Cadence as an EDA company to partner on specific products that are running into an obsolescence problem. So you do the upfront search for components to keep the current systems alive in parallel with doing some new development work on redesigns. But the key there has to be that it needs to follow commercial best practices for those design methodologies. And those best practices go beyond just design, which is what most people think of when they think of development, but it includes the full range of all the engineering disciplines that go into developing a product. And also, in my opinion, it needs to include the right kind of planning up front, if you will, a commercial strategic marketing effort to fully understand the full life cycle of a product and plan for supply chain accordingly.
Thanks, Dave. I mean, this is a pretty big topic, and there's a lot of moving parts in this, and I can see where companies like Integra can really make a difference in those pieces. I'm curious in terms of the broader view. When you're saying these words, it comes to my mind this concept of digital engineering, to be able to plan the obsolescence even at the design stage, to be able to swap these things out in process, to have a continuous development and upgrading of your systems. I'm curious if Kevin, Vern, or John have any comments with regards to that.
Well, I have plenty of comments, and I just don't want to hog all the time. So I'm gonna defer to the other two gentlemen first.
And I'll let you go first, Vern, if you'd like to, and I'll follow.
Yeah, sure. Digital engineering and all of the things that go with that is really important for the future. Our customers and most of our competitors and our company as well want to be able to design and understand and evaluate systems before they actually get fabricated. And ideally, done the right way, you can also understand how to evolve the electronic components within those systems to address some of the challenges that we're talking about, either from an availability or a security point of view. So yes, I think digital engineering is important and will become more important into the future.
And Terrence, if you could put up my slide, I'll talk to it through that slide as well. Okay, yeah, and I'm going to come at it from a different angle again. Obviously, when we talk about mission systems, there's production that's going on down at the foundry level. John's company, the kinds of things that they do, the security that's required for their supply chains, and then all the way up through this integration manufacturing that GTS does. And so what I've done here is I've kind of put the entire, I'd say, the solution space up on a single slide here. And my perspective on this is obviously going to be led by the kind of manufacturing that we do. We don't do the kinds of things that Integra does. I really appreciated what Dave said there. We're not looking at how do you enable the first question where we're looking at can you do offshore types of secure supply chains. We don't really look at that. I mean, we certainly have to inspect. We have to do all those processes we described. And I'm sure that there's going to be more discussion of that in the panel as well, because I know there's some great technologies, that are control technologies that we'll probably get into here. But what I want to discuss, and I'll go through the slide here just very briefly, is that we're in a present situation where we've got supply chains for all of those things that are in that pyramid there. And then we've got state actors and we've got other folks that are obviously trying to corrupt our supply chains. What we do is in that center blue arrow that comes up the middle. So you'll see the common processing systems about halfway up. You'll see the kinds of controls that we currently implement next to that. And underneath that, I talk about emerging technologies. That's something that we're looking at. So companies like Integra and Cadence are something that we're very interested in when we put together, the end product, or we put together something that is primarily COTS based, but needs, government DoD implementations as well. So what Dave talked to, I think, is really important here. One of the key things that we're focused on, and I'll talk a little bit of background here, GTS, after having a long time doing DoD mission critical systems, we moved into NSA in a program there called the Commercial Solutions for Classified. That program actually, we basically became a trusted integrator where we're layering solutions. One of the issues that we ran into was supply chain related, in that we were looking to leverage microserver technology, and it's the latest and greatest form factor, allows you to put things into very low swap configurations to use airborne or to use in mobile, edge, other kinds of things. The important thing about microservers is that they're proliferating very, very rapidly, and China's making a lot of them right now. So very important from a supply chain perspective to understand that. What we've done is we've looked at that and we said we couldn't at that time find a US manufacturer of those. started building them ourselves. But one of the key things that we're doing that I think touches on what Dave spoke about is the idea of modularity. And what we're doing there is that we're thinking, try to stay as pure COTS as you can, as easily upgradable as you can, but make it modular so that you can swap out modules and enable a microserver within a small component system to be swapped out so that it can have functionality in the commercial space. So if you want to use it for commercial communications, it works there. Or if you need to use it for NSA or for one of the secure capabilities in one of the services, you can do that as well. So that's been the focus of what we're doing. We have a whole product line called Next Gen, which is it's really focused on CSFC capabilities, but the microservers are the core to that, and understanding that you want to have something that's like an iPhone 6 that retains about 70% of its content to iPhone 11, so that you understand how to reduce those costs. But that's all I got there.
All right, Terrence, if you could put up the microchip slide. Okay, one of the advantages that, and to the benefit of, from the aerospace and defense standpoint, microchip and previous to that microsemi, we've engaged in a non-obsolescence practice, which is really helpful. Some of these devices have been built for literally 60 years. And these are mill and space qualified devices. They're known to work in space and in some of those robust applications of which they're designed in. With the microchip acquiring microsemi, that gave us much more onshore resources as it pertains to wafer fab. So we have 4 onshore fabs. So we tend to handle the aerospace and defense systems components cradle to grave, which is obviously of great benefit when it comes to trusted and reliable. Now, in certain instances, on some of our FPGAs, now this is a previous generation, we're about to spin Gen 6, and Gen 6 will probably, I can't really get into most of the details on it, but the way we use a procedure in order to assure trust, we do most of anything we get, any source material we get from overseas, we have a reliability program such that anything that's brought on shore is done by one of our trusted either design centers or one of our trusted facilities to make sure that a part can't get compromised if it's ever overseas. So anything like encryption, programming, all that is done on shore, and there are blockchain type safeguards and physically unclonable functions that we incorporate into our design. In this instance, it's an FPGA. These are one of the few parts that we don't necessarily handle cradle to grave onshore. So this is how we implement one of the most, if not the most secure FPGA that's used in the A&D world, and this is how we do it. So in terms of any other procedure that in terms of a technical solution to have access to microelectronic components that come offshore, if there's no other option, I believe this is probably the model. Or when it comes to things that aren't necessarily programmable logic devices, whether it be some kind of mixed signal or diode transistor, is to implement a mill type testing in order to, on a lot by lot basis, guarantee that reliability. So if something does work its way and statistically it can be removed and any infant mortality can be removed, so you don't get a catastrophic failure on a system. So I think if you have to go offshore, there are certain procedures that can be implemented. But unfortunately, we have defined trust for ASICs, but I think when the government talks about big T trust, little T trust, assured quantitative assurance, well, those are great buzzwords, but you really have to define them at some point and put them down in black and white to say, here's quantitative assurance. It can be test to an LPD of whatever, and that will assure your reliability statistically. So I think, once again, outside of the of not handling cradle to grave components, implementing statistical analysis or statistical specifications to assure that you're going to get a part that's not going to fail. And I think that's at that stage, if that's the only choice, that's the only choice.
I can see how reliability is hand in hand with security. You could have something that looks very secure, but built in a way that's unreliable. And that's the same thing as being an insecure system. So I hear you, John. I think that's a really important thing, that we have some sort of secure chain of these custody throughout this entire period, whether it's blockchain or other kind of devices. Any other thoughts? Vern, Kevin, Dave?
Yeah. Would you like me to go through my material, Terrence? I don't want to use up all the time, and I know we want to leave some time for Q&A from the audience.
We've got plenty of time.
Okay. So this, I think, augments and adds to some of the conversation of the other panelists in terms of how we think about the supply chain, the security, the availability. This picture, I think, gives a good sense of what happens on some of the defense programs with respect to mission critical electronics and commercial electronics, and then some concepts that are being explored to address security across those different products. So I'll start in the lower right here, where you see a cartoon of a weapon system, a tactical fighter with a digital array. Think of that as maybe a radar. And inside of that radar is some custom ASICs, some custom electronics. So often those systems cannot be built purely with commercial chip technology. The frequency ranges, the power levels, you can imagine just from that cartoon what some of those requirements might be. So moving to the left of that picture, you see an example of a module and some of the MCMs, and further downstream, you see some of the ASICs. That's an example of a mission critical component that we would design for a military system. Now, this particular design happens to be at 14 nanometers, but eventually we'll want to reduce that to other, more advanced node sizes. And now you're starting to ask the question, well, if I need to have this mission critical part, where does it get fabricated? We might design it, but who fabricates it? And if there's no place within the US to do it, and we must fabricate this device at an overseas foundry, how do you ensure that you're getting back what you designed and only what you designed? Further downstream, this by itself doesn't complete the system, right? This might be a digital transceiver module in this case, but it has to interface to secure FPGAs like the one John just described, or other GPUs, other types of processors. So the systems wind up being combinations of commercial and mission critical custom ASIC technology. We, of course, can't discuss the exact solutions that we use to secure our systems, but these capabilities that you see here are exploratory programs that we're working on with customers. They look at ways to address vulnerabilities based on different attack vectors that you might see throughout the buildup of a system like this. So something like SHIELD, a DARPA program, is about embedding IP inside of a die, to fingerprint, protect, and secure an ASIC that might be fabricated overseas. Other concepts include, you see references to obfuscation here. So somebody might design and build something, but it's not obvious what it is until it gets back into a secure environment where you can, complete the process of turning that raw ASIC into something functional. And, a number of other techniques here. I'm not revealing anything that's actually used or securing a weapon system. I hope you understand. But these are just some examples of things that are being researched. And really the point here is it'd be nice if we had availability to everything all the time. Earlier you said, well, why is it everything's offshore? Well, those foundries are being subsidized, right? And it's easier for them to keep pace, whereas, within the US, that's not the case. So there's a commercial challenge just on the availability side for some of these foundries. So if you're unable to have full access to everything you need, Now I have to introduce a variety of security methodologies, security techniques, so that I have both access and security at the same time. So hopefully this provides a little bit of illustration and a point of view on, what is mission critical electronics? How does it fit with COTS? How do we think about security and solutions across this trade space?
Yeah, I'll just add a couple things into the back end of what Vern was speaking about there. So at the level that we develop to, we're working with our foundry partners, to those suppliers, and making sure that we're getting the latest that they have in things like unclonable features and things like that. We're also working that effort at the board level too. And so as we move forward with things like microservers, we're taking those thought processes like modularity, using, tapping heavily into pure COTS, but then making things modular so that you can upgrade and replace rapidly, and include in those things the latest generation of these types of security features, like unclonable capabilities that you have. Those are the kind of things that we're working towards. But to the latter part of what Vern was talking about, it's really important to understand that as we look at this, and of course we've seen the new administration has executive orders that are focused on this as well. It's not just the NDAA, and there's a 100-day period in there, and then there's, I think, a year-long period in there. And John would make the point that we've got a lot of studies and we know a lot already. I would say that from our perspective as an integration manufacturer, we have seen very little discussion about that level of industry support. In order to have the base that actually builds the components and the end components, right now we're sending that overseas to be done, even though it might be using trusted foundry level components. So we've got to fix the whole issue. That's why my slide talked to a comprehensive solution, and I think we need to look across the board at the entire supply chain process. I listed the rare earth elements in there as well. They've got their own solution, but I think all the rest of the way up, it needs to be a coordinated activity that looks at how we're actually being abused right now and how to fix those things.
No, fully agree. Thanks, Vern and Kevin and John and Dave, for your very insightful comments, particularly on the solutions and what your organizations are trying to move that football forward, whether it be inches or yards towards that goal. So thank you so much. I think that we're all seeing this from the trenches and looking upward and seeing that there's really a need for leadership at different levels in order to make us all successful. And I'm curious, as you had said, Kevin, I want to pull that thread a little bit more about the regulatory power of the U.S. government. What can the U.S. government in both the regulatory, legislative, and even policies and their initiatives do to help enable companies and organizations, whether it be for-profit or nonprofit, to innovate and develop capabilities onshore for the long-term health and stability of the environment? You talked a little bit about subsidies from the competition. I'm curious what would work here in our more capitalistic environment. And John, if you could switch over to just the slides or switch off the slides, that'd be really great.
Yeah, thank you. So I appreciate that. And we mentioned before that there's an awful lot of subsidization that's going on in foreign manufacturing. In the end, you have to have a level playing field in order for us to be able to even hang on to what we have. And so the kinds of thoughts that I have there, we need to look at when we're building mission critical or critical infrastructure, and we need to either establish requirements or rewards for selecting U.S. manufacture of these things. I think there's a lot of ways to do it. I mean, we've seen the TAA, the BAA process. I don't think that works very well. There's a number of reasons why it doesn't. It gets interpreted in many different ways by different acquisition agencies, and the 50% rule is, I would say, it's less than effective. So when we look at those things, we need to come back and look at them again and make them better. We need to look specifically at technology sets that are required and are high risk areas, and make those either reward or regulate confined. Those are some of the things that I think have to happen. And then we need to look at things like medical, banking, telecommunications, energy, utility, transportation, and figure out how they fit in there as well. Because in the end, if you can't do commercial and you're only reliant on doing DoD, you can't compete. So we've got to figure out, how do we position ourselves for the first stage of getting re-competitive? And I think that's the biggest thing there. One of the things we can do on the government side is get rid of LPTA. Low price, technically acceptable, has essentially caused, a boon for Asian microelectronics manufacturing because it's much cheaper. We've got to come up with different approaches to those kinds of things in acquisition, so that we're at least on a level playing field. Those are the thoughts I have.
Yeah, I'll say a little bit on this, and then I'll first qualify it by saying that a lot of this is commercial and it's outside the swim lane of my company, right? So recognizing that right up front, but this is largely a commercial sector challenge. We want to have these advanced node foundries. We want them on shore, yet they're very expensive, and it's left to the individual companies to figure out how to make that affordable and make the business case work. And that's in contrast to these overseas foundries where they're subsidized and they don't have that challenge, right? So one of the fundamental things is, how do you help a domestic company overcome that hurdle, right? Is it a government infusion of funding or something else? The other thing that's interesting to me is when you kind of look at the overall distribution of value, most of the intellectual property, the innovation, is done within the U.S., right? The design work, what is creating all of these ASICs, and so it seems that that should create a lot of opportunity for leverage and maybe things that aren't being fully utilized. So we create all the IP, we create all the designs, yet we're not fabricating them. So why is it so imbalanced in terms of risk? Or leverage? I'm not suggesting I have a solution to that, but I just think it's interesting that all the IP creation is domestically, yet we're highly vulnerable on the fabrication side. It seems like there's something to be explored there.
Well, I kind of echo both Vern's and Kevin's points. Once again, I'm really focused on the A&D, the mission critical part of the microelectronics applications. So in terms of regulatory or legislative to say protect the mission critical, or at least sustain the mission critical devices, I think that if a company I really, on state of the art, I really believe that there's a lot of private money that's going to follow state of the art only because of how big the market is. Now on the mission critical, that's a whole other ball game. So to sustain those parts, I think you have to create incentives, whether through private public partnerships or tax incentives, for companies that are actually supporting military and space applications, because that's the part that's shrinking in the supply chain. Read any industrial base report, read any microelectronics trade study, it's going to tell you that. So in order to build that up to protect the DoD applications, I think that's the mission critical is where they need to focus, because I think on the state of the art side, there's always going to be money there. And to Vern's point, I remember him making this point in a previous panel. If we are protecting our intellectual property because we, enforcing things, because we are losing billions to people that are stealing our technology, and if we would enforce that, that's a whole other revenue stream. So I think going forward and trying to merge these two concepts, getting involved with a military space application that is commercially viable. And I think a good example of this would be the HPSC from NASA, high performance space computer, where it has it's going to be applicable to 28 or so different platforms for both NASA and the A&D world. But at the same time, there's an automotive application. once again, you come back to the situation where you could run into an ITAR dilemma. But be that as it may, the only way for those two product life cycles and applications to merge is to build something, from the DoD end and the NASA end that has a commercial application to make it commercially viable going forward and keep factory utilization at the highest possible.
So I'll jump in here if you don't mind. I agree with everything that's been stated by the other panelists. I do believe that the public-private partnerships can be successful within the defense electronics world. DoD program offices need to work together with various prime companies to map out near and long-term requirements for components. But bottom line is there's not a one-size-fits-all solution to this supply chain concern. In my view, the U.S. government needs to continue establishing a trusted network of both large and small component manufacturers in every technology segment that is of interest to the products that they produce. And they need to put in place for the DoD a commercial state-of-the-art development methodology, as I mentioned earlier, that goes all the way from the design, all the way from planning through the entire design and development cycle and all of the back-end activities that have to happen to deliver a full supply chain. I also believe that for smaller private companies, the government should consider funding some development centers that will provide a use of expensive tools and various resources needed to develop a full range of components. An example of this that I've seen is the Air Force Research Lab, which provides many resources to companies to help them in developing state-of-the-art solutions. Not everything has to be a bleeding edge, state-of-the-art component technology. We the various suppliers need to be designing components that meet the requirements of the system in which they're going to live, while keeping an eye on making cost-effective solutions instead of just migrating everything to the latest, greatest technology.
No, I really hear you. These are very, very good comments. They touch upon a lot of different areas, both in areas where our government and society can look into and support, and also other organizations like the IEEE to be able to establish standards. Maybe we should look into a supply chain standard, much like what the IEEE did for the Wi-Fi 802.11b, C, D, E, F, G, H, I, right? Maybe we could have something like that so that everybody's not trying to boil the ocean. They're just boiling a couple buckets in the ocean, and then in parallel are able to then create something that is very robust. We actually have a very good discussion on the comments talking about how the playing field's never going to be level. We should realize that and move forward. We should realize to learn to survive in this period, and then get support from the U.S. government, forge ahead in the form of incentives. I think that's one thing that the government could do, is provide very distinct incentives to be able to level this playing field. Or actually, I would like to have it not level, unfair, that we would have an unfair advantage over the rest of the industry. So one thing that they've been talking about back in there is continuous innovation, and in terms of leadership, it spells actually and moves into our next question, which is the future of leadership. Each of you are leading very strategic and technical solutions for this very, very important challenge that has national security concerns and implications. What pivotal moments has led you to this position and where you are right now? And what organizations like the IEEEUSA can do to help develop future leaders? I'm curious about your comments about this topic.
I'll take that. It's hard for me to define a pivotal moment for Integra, as we've been in this business of procuring, testing, qualifying high reliability components for over 3 decades now. However, we have seen a recent increase in the critical needs within the DoD, and are working with them on some specific product areas to pilot some long term U.S.-based design efforts, as I mentioned earlier, and manufacturing for critical systems. Integra specifically is joined or is a member of the DMA Trusted Semiconductor Manufacturing Team and results in womb to tomb, cradle to grave, as was mentioned earlier, device builds with various vetted companies that are contained within this trusted network that I referenced earlier in my comments about what the government can do. So what can IEEE do? I think maybe establish some working group committees to drive forward this distributed network of companies within the trusted supply chain in such a way that economic incentives are there to drive this structure and to give us, hopefully, at some point, an unlevel playing field, as you mentioned, Terrence.
I'll give you a quick story to follow up on Dave there. And my focus is really on, I think the end of the question is what IEEEUSA can do to develop future leaders. And so I'm gonna tap into my background. I did 25 years in defense and aerospace, but before that, I was a pilot for 25 years for the Navy, for 22 years for the Navy. And there was a pivotal time for me there where it made me realize the value of engineering. I was a young lieutenant. I was flying off the Enterprise, got a good deal to fly back to San Diego and had 5 people on board. And we got halfway there, about 45 miles away from the carrier, and had a massive transmission oil loss. So we had to turn around, start doing emergency procedures, head for home. In the meantime, we made it back to the ship. And the reason we made it back to the ship was because Sikorsky engineers developed what's called an emergency lubrication system that just poured about 1.5 gallons of transmission fluid on the high-speed bearings and allowed us to make it back to the ship. When I pulled the speed selectors back on landing, the rotor system went around one time, no rotor brake, but it got us back. And when I was injured and ended up leaving the military, defense and aerospace was very, very important to me because I already understood the value of these double and triple redundant systems that had been developed that saved 6 lives that I was one of. So the point that I would make here and draw away from this is that young engineers need to understand the importance of what they're doing. On a routine basis, they're doing great things. They're developing wonderful things. That needs to be drawn full circle so that they understand what they're doing is vital and it saves lives.
All right, Kevin, I'm going to address this, but it's hard to talk to a pivotal moment when I got to follow that story. Anyway, there have been several pivotal moments over the years, and most of them have to do with maintaining parts, or pardon me, product types or product lines. And we're at a pivotal moment right now, and over the last 23 acquisitions and having to do integration and consolidation, when you see what's happened in the industry, both in the primes, subprimes, and flowing down to the components manufacturer, you see the consolidation in the industry, which makes our business model, and once again, I see this from the aerospace and defense land. So let me start by saying that it makes our business model that much tougher to maintain. So in terms of, we're in the, like I said, we're in a pivotal moment now, having to move a product line from one facility to another facility and then requalifying thousands of different parts. Now, we've done this twice before, and it's not easy. So we're at a pivotal moment right now when it comes to supply chain maintenance and obsolescence of our source material. In terms of IEEE, and once again, I see this from the defense and space perspective, the talent in terms of future leaders, everybody's kind of going out into the commercial world, to the Googles, the Facebooks, and the iPhones and Apple, and that's all the exciting stuff. So when you have major victories or major technological breakthroughs or successes like Perseverance and Rover and Ingenuity, I think, we really have to do some outreach. I mean, I'm talking about, K through college to make this industry exciting again, to draw some of the talent. Because if you're not drawing that talent, you're not going to find very, very good leaders. They're all going to be running around in a different industry, and it's not necessarily going to help when it comes to security and defense. So I would say, putting forth those technical successes, I remember at one point we became so accustomed to, the space shuttle succeeding in missions, and when the first one blew up, that's when everybody decided, wow, this is, not realizing what accomplishment and what it takes to guarantee the safety of astronauts. Now we're in Mars, where we've got, devices on Mars. So I think you really have to play up that and get a generation of kids and college students more excited about the industry in order to get that, to attract that kind of leadership for future generations.
Yeah, I like what you're saying there, John, and I'll amplify it as well, because I think, one of the things IEEE can do, and particularly in driving leadership, is to continue to ask the question, what is next? Make your own pivotal moment. The reason that these advanced node foundries are charging forward, because everyone's driving Moore's law. Right? So what happens after that? What is the next technology? What's going to happen when, the node size can't be reduced anymore? Maybe we should apportion some of our thinking towards that. Not that we can ignore the access and the availability of these advanced node technologies, but in terms of leadership, we can't just chase. All right, we got to address that, but then go beyond, right? And I think that's a key role for an organization like IEEE in shaping our future leaders, our young engineers. I think it goes right along with what you were saying, John, and inspiring some of our emerging leaders in the educational levels.
No, thank you, Dave, John, Kevin, and Vern. Thank you for all of these comments. I'm really taking that to heart. Definitely organizations like IEEE and the other technical-oriented societies have a very tall order to fill for the future. And I think definitely getting them excited, getting the next generation excited is always one of those tasks. But I think one thing that's unique about United States is that we have had that heart to lead. We've led in so many different ways, both culturally and in engineering and in technology. To maintain that leadership is not to look behind and see our competition coming up for us. It's going after that prize, that next thing, and not even looking back, right? And just going so fast that there's no way to catch up. I think that's the sort of technology leaps that we need to keep going. Not just look at buzzwords like AI or quantum computing or blockchain, but really to look for what is that real essence, that next thing that nobody else has thought of, these fundamental pivots in technology and capability. So really excited to hear that. We're at the top of our hour. Just really great discussion, and I wish we had another hour to be able to talk about all the other societal implications of what we're doing. But I just want to thank the panel for everything you're doing right now in your roles, both on an organizational level, really putting in those pieces to make a secure, reliable access to high technology, high technological components, but also in your personal careers and in what you do as leaders, to be able to push that envelope and inspire all of us to take those next steps, to be able to set up that next generation. So any last comments from the rest of the team before we close?
I'll make a quick one. Every time I get to do one of these things, I learn things from the other panelists. No exception today. A lot of great conversation. And Terrence, thank you so much for setting this up. I thought it was great.
Thanks.
Thanks, panelists. I'm the same way. I like listening to the guys that are smarter than me.
Thank you very much, Terrence. And you guys, it was very interesting, and I learned much.
Likewise, I enjoyed it very much. And John, I'm hoping you can email me some scotch, because we're getting to that hour here.
Awesome. Well, it's my pleasure. And if there anything, John, in terms of anyone, I saw some of the comments wanting some access to that slides. If you could put up that slide, if anyone's interested, please do email me at terrence.yo@ieee.org, and we'll get you connected to some of these resources. As you can see, there's just a lot out there, and we're really excited to hear. So thank everyone for the panelists, and I'll kick it over to John for the close.
Thank you so much, Terrence. So everyone, as Terrence mentioned, unfortunately, due to time constraints, we weren't able to get to a number of our audience questions today. If we weren't able to get to your question, you can reach out to Terrence, who will compile all of them and forward them to our panelists. His email has been provided on the screen. Terrence, Kevin, Vern, John, Dave, I'd like to thank you all so much for joining us today. I think I can speak for our audience when I say that we really appreciate having such an all-star lineup of speakers who can give their expert insights into these important topics. Big thanks to Terrence for moderating this entire discussion and for bringing our speakers together. And thank you everyone for attending today's IEEEUSA livestream panel webinar. IEEEUSA's goal is to create programming that is valuable, relevant, and of interest to you. As such, we will be sending a short survey to all registrants after this event and would love your feedback. We value your opinion and would appreciate if you could take a few minutes and share it with your thoughts. Check back daily on our social media for future livestream updates, and we hope you all have a great rest of your day.
Take care.
I am trying to build a sustainable electronics industry. The things that we have just don't last as long as they used to, but they could. Every time a new gizmo comes out, we take it apart, find out what makes it tick. We need more engineers in the world. Engineers make the world better. They are designing the systems that keep the world working. So that's why I've been involved with IEEEUSA, is I want to see more kids get excited about engineering. We are working with IEEEUSA to create a world where repair is normal again.